Imagine a sound so profound, it's unlike anything you've ever heard, a whisper from Earth's deepest, darkest corners. What if these strange, booming noises aren't just random, but carry secrets from an alien world beneath the waves? Join us as we dive into the enigmatic abyss to decode the hidden language of the ocean's depths. We've all heard the chirping of birds, the rustle of leaves, but what about the sounds from a world where sunlight never reaches? Here, under pressures that would crush a submarine like a soda can, lies the deep sea, a realm so vast and unexplored that it's often compared to outer space. We know more about the surface of Mars than we do about our own ocean floor. While we've mapped the stars, the acoustic landscape of the deep remains a symphony of unknowns. What strange melodies and mysterious crescendos are echoing through these crushing depths? What secrets are they waiting to tell us? Think of the ocean as a grand concert hall, constantly buzzing with sound. In this immense space, sound travels much farther and faster than light. It's the primary way life communicates, navigates, and survives. The most famous performers are, of course, the great whales. Their haunting songs, complex and ever-changing, can travel across entire ocean basins. A blue whale's call is so powerful, it's one of the loudest sounds made by any animal on Earth, a low-frequency rumble that we can feel more than we can hear. But whales aren't the only musicians. The Earth itself contributes to this underwater orchestra. The grinding of tectonic plates creates deep, resonant groans, while underwater volcanoes and hydrothermal vents hiss and crackle, releasing superheated water into the freezing abyss. Even underwater avalanches, or turbidity currents, create thunderous roars as tons of sediment cascade down the continental slope. Capturing this symphony is a monumental challenge. Imagine trying to record a whisper in the middle of a hurricane. The immense pressure in the deep sea requires incredibly robust and specialized equipment. Hydrophones, our underwater microphones, have to be built to withstand forces that could pulverize steel. Deploying and retrieving these devices from miles below the surface is a feat of engineering in itself. Then there's the sheer scale of the ocean. A sound source could be hundreds or even thousands of miles away. Its signal distorted and faint by the time it reaches our sensors. It's like trying to find a single voice in a stadium of millions, all while blindfolded. Despite these hurdles, what we have managed to record is nothing short of astonishing. We've heard the clicks and whistles of dolphins and the eerie moans of seals. Scientists have even identified the signature sounds of different types of icebergs breaking apart. Some zing, others groan, providing vital clues about climate change. Each recognized sound adds a new note to our understanding of the ocean's complex web of life and geological activity. But it's the sounds we can't identify that truly capture our imagination. This brings us to the heart of the mystery. Welcome to the world of acoustic forensics. Scientists use global networks of hydrophones, like the one operated by NOAA, to listen in on the deep. These sensitive instruments were originally set up during the Cold War to detect enemy submarines. Today, they eavesdrop on the planet itself. When a strange sound is detected, the real detective work begins. By triangulating the signal from multiple hydrophones, researchers can pinpoint its origin. They analyze its frequency, duration, and pattern, comparing it to a vast library of known sounds. But some sounds defy all classification. In 1997, hydrophones across the Pacific Ocean picked up an ultra-low frequency, high-amplitude sound. It was powerful, rising in frequency for about a minute, and was heard by sensors over 3,000 miles apart. It was nicknamed the Bloop. For years, speculation ran wild. Was it a colossal, unknown sea creature, far larger than any known whale? The idea was tantalizing. The sound's profile didn't match any known animal or geological event. The mystery of the Bloop became a modern legend. It wasn't until years later, with more advanced data and a better understanding of ice acoustics, that scientists concluded the most likely source was a massive ice quaking, enormous iceberg cracking and breaking away from an Antarctic glacier. But the Bloop is just one of many sonic enigmas. There's upsweep, a long train of narrowband upsweeping sounds that has been detected seasonally since 1991. Its source is located somewhere in the Pacific, possibly related to volcanic activity, but it remains unconfirmed. Then there's Julia, a powerful, moaning sound recorded in 1999 that lasted for about 15 seconds. It was loud enough to be heard across the entire equatorial Pacific hydrophone array. The likely culprit, a large iceberg running aground off Antarctica. And we can't forget, Slow Down, a sound recorded in 1997 that, as its name suggests, slowly decreases in frequency over about 7 minutes. Its source is also a mystery, though its sonic signature resembles that of a stick-slip motion, similar to the sound of friction. The leading theory points to a massive iceberg moving over the seabed, but like the others, it remains a puzzle. Each time a mystery is solved, like the Bloop, it doesn't diminish the wonder. Instead, it deepens our understanding of the planet's immense power. It tells us that our world is capable of producing sounds on a scale we previously thought impossible. And for every puzzle we solve, new ones emerge from the depths, waiting to be deciphered. These breakthroughs, driven by improving technology and data analysis, are like learning new words in the ocean's secret language, slowly revealing stories of hidden geological processes and perhaps, one day, even undiscovered forms of life. However, the ocean's natural symphony is now facing a new, disruptive noise: us. The constant hum of shipping traffic creates a pervasive low-frequency fog of sound that masks the calls of marine animals. Imagine trying to have a conversation next to a busy highway, 24/7. This is the reality for whales and other creatures that rely on sound to communicate, find mates, and navigate. The intense, explosive blasts from sonar and seismic airguns used for military exercises and oil exploration can be even more damaging. These sounds can cause temporary or permanent hearing loss in marine mammals, disrupt their feeding and breeding patterns, and in some extreme cases, have been linked to mass strandings. Our acoustic footprint is expanding, turning vast areas of the ocean into a noisy, confusing, and stressful environment for its inhabitants. The good news is, we are starting to listen more carefully. Scientists and engineers are developing groundbreaking technologies to better understand and mitigate our impact. New, quieter ship propellers are being designed. Advanced, real-time acoustic monitoring systems are helping ships avoid sensitive whale habitats. Researchers are exploring passive acoustic technologies that listen for the Earth's natural signals instead of blasting it with artificial noise. The future of deep-sea exploration is acoustic. Imagine fleets of autonomous underwater vehicles, silently gliding through the abyss, mapping the soundscape in high definition. What will they hear? Perhaps the first-ever recording of a colossal squid. Maybe the faint, rhythmic pulses of a previously unknown biological process. Or could they pick up something truly unexpected, a signal that doesn't fit any known biological or geological pattern? The ocean is the most likely place on Earth to harbor life that is truly alien to us. The possibility, however remote, that we might one day hear a sound of non-human intelligence from our own planet is a thought that fuels the dreams of explorers and scientists alike. From the songs of whales to the groans of the Earth, the deep ocean is a world defined by sound. We've learned that many of its most profound mysteries were not monsters, but the awe-inspiring power of our own planet's natural processes. Understanding this hidden soundscape is crucial, not just for satisfying our curiosity, but for protecting the fragile ecosystems that depend on it. The silent depths are speaking, and we are just beginning to learn their language. The auditory adventure beneath the waves is far from over. It's a journey into the unknown, a quest to decode the very heartbeat of our planet. What do you think is the most fascinating mystery sound from the deep? And what do you believe we might discover next? Let us know your theories in the comments below. If you were captivated by the secrets of the abyss, don't forget to like this video and subscribe for more journeys into the unknown. Thanks for watching.